All right. Hello, everyone. Sorry, was just finishing up a couple things there, so we're starting just a couple minutes late. But today we're going to wrap up MySQL. We're not really doing a whole lot with SQL. You could literally do an entire course on SQL and get into things like triggers and PL SQLs and all the different constraints and things like that. And it's just beyond the scope of this course in terms of I just want to get you started going down the path of SQL. And yes, I'm wearing a T-shirt today. I can put on a button up if people prefer, but eh. Um, but with that today, homework 5 will release tonight. I haven't finished it yet. I'm almost done. It is you're going to read in a couple, well, more than two JSON files. These JSON files are going to then sorry, yes, I do mean homework 6. You are correct on that. Homework 5 is due Friday. Uh, Basically, as you fill out that form that's on Piazza, I am emailing with your grading TA's name. So I did a batch yesterday. Um, I'm going to do a batch here in a second. You need to add your grading TA to your GitHub repository. So I will include their email information in that email that you get. From there, Homework 6 is released tonight, and it's designed to not be particularly difficult. It's just designed to force you to do a little bit of something with JSON, with MySQL, and with JDBC. When is Homework 6 due? Currently, the plan is for it to be due next Friday, but again, with the statement that it's designed to be doable in like a couple of hours is the intent. It's more just to force you to use some of the tools that we've talked about. Um, Again, if as I'm about to release the assignment, I realize it's going to take longer, I will I will change the deadline accordingly. But currently, the planned deadline is April 17. Again, with the stipulation that it won't be much to do. Um, but it's also because I want to do a three-tiered architecture project, which that one is going to need a bit more time to do. When will the exams be graded? They're almost graded. The grades hopefully will be out tomorrow for the exam. There's only a couple questions left to grade, but it's just been a matter of between this class and my other class, I simply haven't had the time to finish with the grading for it. For context, I have pretty much worked from about 7 a.m. to 11 p.m. the last like 4 days, counting Sunday. So I just haven't finished yet, but it's almost done. And I apologize. It's taken as long as it has, but it certainly won't be out later than tomorrow night, and hopefully tonight. But I have to get multiple things done. The homework is currently the more urgent of the two. From there, homework 6 will be released tonight. That is again JSON MySQL. There will be a quiz 7 released tonight. The quiz will be on JSON, XML, and on MySQL. XML is not in the homework, but it is quiz material. It is potentially exam material. I just am gonna do JSON for the project because I think it's easier to work with and it's easier to kind of get started with. Any questions about any of the announcements today? All right. So we're gonna pick up today with this is MySQL day 2, and click to add subtitle, I guess. Let's go with April 9. I haven't uploaded these slides just yet, but they will be uploaded soon. This is just briefly going to get into how to interact MySQL with Java, and then how to do some basic joins, that is, have multiple tables communicate with each other. So let's start by talking about the Java JDBC. This is a means of connecting the Java programming language with a MySQL server. And I have an example of this that's not uploaded yet, but it will be uploaded immediately following class. And I give you a web link here. If you just Google the connector Java, you'll see this page. And the one you want to download is the platform independent one. And this is basically to connect Java to a MySQL server. So the link is here. I'll make sure the link's visible. But it's just a jar file that you have to download, and at this point it shouldn't be too big a thing to say download a jar file and put it into your project, as you've done that a few times already. From there, what that file will eventually look like, the thing that queries. So I'm building off the same database we used yesterday. So if I just quickly go into MySQL, and then I type in my super secret password, which is Hunter2. There we go. From there, this is not visible. There we go. From there, and I'll blow up the font size here real quick. I'm going to use the same database we used yesterday, so that was called use SDE underscore day1, and then select star from students. I get this table. This is something we covered on Tuesday. Nothing new. But how can we do this in Java? That's the question. So from there, we have our Java project. You'll note that in my project structure in my libraries, I imported the jar file that you download with that connector. So that's the first step, is adding the relevant library. You're also going to use, and this is built into Java, this is a built-in Java library, java.sql. That library will be used as well, so you're just going to import java sql.star. Although you can import the specific libraries if you want, this is just going to get all the libraries you need. From there, you're going to have a URL, and this URL, and I have this described in the slide, this URL might look something like this, and what it's going to do is it's going to specify what server you're accessing and how you're accessing that server and that database. So specifically the first part, JDBC MySQL. This means I'm accessing a Java access point of a MySQL server. There is actually, for example, JDBC Oracle. This would be for an Oracle SQL server. We're using MySQL because I'm not expecting you to pay thousands of dollars to do the homework. So from there, most of you probably just set up your server as the local host with the default settings. So localhost means this computer, so, right there. Localhost just means the computer that you're currently on. You can replace that with an IP address for a remote server if you want to use a remote server's MySQL. And then this is the port number. And often when you need to do some type of traffic over a network or interacting with a server, you need that server's port number. That is basically the door that you're going to use to access that particular server. The default is 3306 for MySQL. Unless you've changed that, it will be the same. If you're not sure, you can always go into the MySQL workbench and you can go to server status, and the server status will list the port number right there, 3306, that I'm using. From there, the database name. This is the specific database on the server I'm using. Remember that you can have multiple databases on a server, and currently we are using the SDE Day 1 database. So we're building off what we did last time. So that's where the string URL comes from, and you're going to have to define this string at some point. Additionally, you'll notice in my code, I have the username as root, And then I have this, which generates my password. It pulls it from a file. And the reason I did this was I didn't want to type my password on a Twitch stream. Even though I don't reuse it, I still don't want the password out there. So I put it in a file, which I'm not going to open. And all this does is this is just a simple scanner to read that file. Often you will set up, once you get into more advanced MySQL usage, you may set up the properties file that you access for the username and the password. You can hide the password with some type of encryption. Um, the point being, for the sake of this class, it would be fine if you said in the homework string password equals hunter2 or whatever your password is. Oh no, I typed my password. By the way, if you don't get hunter2, it's kind of an internet meme regarding passwords. So what I'm trying to say is I'm old. The point being, that would be fine for the homework. I would just very, very strongly encourage that you set up your password to not be a password that you've used elsewhere, as we will have to look at your code to grade it. So all this is this is getting my URL, my username, and all of this is just getting my password. From there, we can define a query simply as a string, the string that we would write in the database. So for example, if I were to write select star into students, I would get this. If I did select star from students, where name equals Jack. Oops. Sorry, not where for first. Excuse me. There is no name. Where first name equals Jack. There, I only get 2 records. By the way, SQL is not case sensitive. Can you set the password per project, or is it the same password you use when you set up MySQL? So for the sake of this assignment, just use your root password. And here's why I say this, by the way. Actually, the directions will tell you what username and password to use, and it will probably just be root and password. And the reason is this. When we're grading, we're not actually going to log into your SQL. You're going to write a .SQL file that creates your tables. And then you're going to write a Java file that populates the tables. You're going to write a separate Java file that queries the tables, and then you're going to use that Java file to produce a JSON file. So you're going to have basically 3 different parts to the homework. One sets up your database, or sorry, one reads in a JSON file and uploads it to a database. This I'm screwing this up. The first part is you're creating the database tables. That's part 1. Part 2 is you are reading in a JSON file and populating that database. Part 3 is you're querying that database and outputting it to a JSON. Those are going to be the 3 parts to the homework. And as such, we're not going to use your database. Like, I'm not going to try to log into your computer's database. I'm just going to use your SQL file and set up my own database for the sake of grading, if that makes sense. So we'll probably give you a specific name and password to use when you're setting up the database for testing, or you can just change it the last second to like root and password. It's just so that way we get some kind of way to query your database. All right. From there, we define our SQL string, and then from here, this is all code for setting up the connection. So the first thing we need to do to set up the connection is we need to actually more or less tell the class where to find the driver. And this line of code, it's not something you may have seen before. Basically, all you're doing is you're telling the class, hey, this is what driver I'm using for JDBC. You don't really need to worry about exactly how this works. You pretty much are just going to copy and paste this class. From there, we set up our connection. And notice when we set up our connection, we set it up with the URL to our database, with the username, in this case root, and with the password. From there, we we create a statement object, but this statement object, think of it like a palette. So this isn't a finished statement, rather is a palette that we are going to paint a pretty picture of a SQL statement on. And we use that statement to execute a query. And I want to highlight just statement execute query first. And I actually have this highlighted here. So we can define our statement first by just simply defining it as a string. This string is exactly the same you would type into a MySQL command line setup. You would then create the statement object from the connection and then say statement.execute query and that string. And by the way, you can actually use a statement multiple times, statement.execute query multiple times. Point is, we just say statement.execute query and then whatever this string is. And by the way, you can of course just write the string there, not use SQL, but this is allowing you to maybe predefine several queries and run them in different order. Now from there, this will work whenever your query is something like create table or drop table or anything like that. But if you're doing a select statement, the whole point of a select statement is to get this result. And this result is called the result set. And to use that, we would simply define an object result set and set it equal to the output of statement.execute query. From there, this result set, you can think of it like a list of results. And the way that we're going to look at this is while rs.next, this is like an iterator, how you would use an iterator. This gets the next result. If there is no next result, this statement returns false. So we can just simply do while rs.next, and that will be used to access every result. From there, we're querying students. So we have the ID, which is a number. So we do rs.getInt, and I'll zoom in a bit just so rs.getInt, rs.getString to get a string field. Forgive me as the auto sensor blocked the word there. Would blank just be false immediately if the yes. Yeah, it might have thought you were maybe saying arse. I don't know. rs.next would be immediately false if there were no results. So for example, if I change this query to be where first name equals Jeff, which I don't have any students named Jeff in my table. Oops. If I just did this, the result, this query won't return anything. Oh, with a dot in the middle. Yeah, it is. I understand that. Yeah, that will work. Okay. So if you notice here, nothing prints, and the reason nothing prints is I don't get any results from this query because I don't have any students called Jeff. But if I delete this and just get all the students, you'll see that this prints all the student information, and I simply get the results in this loop. And you can store the variables here however you want. You could store them in, say, an array list or an array, whatever you want to do. But the key takeaway here is, and I will upload this file, don't worry, it's actually not hard to query a database. This code pretty much won't change from one database access to another. All that will change is whatever you do with these variables, whatever your program needs to do with this information, as well as you'll change, of course, the query string. But setting up the database connection, everything, that's not really going to change from program to program. So it turns out that if you get comfortable with SQL, this is something that, I learned how to do this pretty quickly back when I was first learning SQL, and it's very formulaic. The SQL, if anything, is the hard part. Any questions on JDBC? And yes, there's a bunch of these annoying, like, forced try-catch blocks, and yeah, that's. Oh well. Any questions on JDBC? Okay, so moving on. The next thing I want to talk about is database normal forms. So on and let me open that file up. Yesterday we worked on uh, this SQL file in it, and this is going to create our database. Let me screen share here. This creates our database of courses, students. It creates our course table. It populates our course table. It then creates our table of students and populates our table of students. But the entire point of creating this table is to track not just what courses we have and what students we have, but also to track what courses are students taking. Right? We need to know what courses students are in. And so my question to you is, given that we have this database and we have currently two tables for it, select star from courses, and let me select star from students. My question is, how are we going to store the courses that a given student is in? How do I know what courses John Smith is taking? Well, if we were to do this using our existing infrastructure, you might think that we could do something like this. We have a student number, same name, same class year, and then we list our courses taken. So my question to you is, if we were to do this, and some of you may already know this is a bad idea, but if we were to do this, how would we identify, given the table that we have here, how would we identify the courses? How would I list the courses? What field or fields would I use? Right, I would use the primary key from the courses table. I would use the ID because remember, the ID is the minimalist way, the smallest, fastest way to uniquely identify a record. Because every record has to have a primary key, and every primary key has to be unique. So, I could list the CRNs like this. So, John is taking 1, 2, 3, 4, 5 and 5, 4, 3, 2, 1. Deborah is taking 1, 2, 3, 4, 5. Jack is taking 3 courses. This is two CS courses and 1 APMA course, and Jack White is just taking this APMA course. But there's a problem with this. And the reason is, this is not what we would call a normalized database. Is there a way to tell SQL that a column will be a list of values? So there is not, and in fact, it's a bad idea to do so. So in fact, the very idea of storing this information here, multiple pieces of information, a single column, violates a common rule in SQL, and that rule is called first normal form. So first normal form is a rule that says each table cell can only contain a single value, a single piece of information. It also states, although it's not particularly relevant here, it also states that there cannot be duplicate records. So we can't have two records that are completely identical, which already our primary key constraint takes care of that. So what we could do is we could treat this table as, we could just make this table larger. And the way we would do it, one thing you could do, by the way, you can store strings into varchars, and JSON objects, as we talked about, can be written as strings. So you could just store a JSON as a string or a medium text or something in a database. That would technically be fine. But from a standpoint of designing our database, we don't want to violate first normal form. So I could take this table and I could turn it into this. So now John was taking 2 classes, 1, 2, 3, 4, 5, and 5, 4, 3, 2, 1. So we have 2 records. John taking 1, 2, 3, 4, 5, and 5, 4, 3, 2, 1. Now you may be thinking, but wait, student number was our primary key, and now we have a table with multiple primary keys. Putting a JSON object. Well, keep in mind, a JSON object can be written as a string, and a string can be seamlessly translated into a JSON. It's actually the way I would do it. That's just kind of the niftiness of JSON. Anyway, so you may be thinking we're violating the primary key. Well, what we would do here is we would manipulate our table. And the way we would manipulate it is we would add, in addition to adding something like, and let me, this would be CRN course taken, and this would be course taken int 5. Oh, wait, I'm putting this in the wrong table. 1 second. I'd put this in student, and then what I would do is instead of having 1 primary key, I would have 2 primary keys. And that's completely allowed. This primary key is now an ordered pair. And that ordered pair has to be unique. So neither of them can be null, and the combination of them has to be unique. But they don't have to be unique individually. So if I were to do something like this, and I'm not gonna run this script right now because we're not stopping here. But this would be now a valid table, and it's because this row, while it shares the student number, it has a different primary key. But the problem with this is as follows. What if John Smith decided to change their name? What if John Smith decided all of a sudden to go by Stephen, his middle name? I'm one of those people who goes by their middle names. What if John does that? So Stephen. Well, the problem is I could make the mistake of changing the field in one record, but not changing the field in another. And now I have a database inconsistency. My integrity of my data is now lost. So how can I avoid this? So this brings us to second normal form. And our second normal form first has the same rules as first normal form. Every cell contains exactly 1 piece of information. The second normal form is only have single column primary keys. Now the problem is we just talked about how this table we're going to list the student number and the course taken as a primary key. How can we solve this? How can we not violate first normal form? That is to say, only 1 value per cell, and not violate second normal form, single column primary keys. Can anyone think of a means that we could do to have second normal form while still preserving this data? I'll give a minute and then I'll proceed, but I do want people to at least attempt a solution. Anyone? Bueller? Bueller? Okay, well, one way to solve this problem would be rather than have 2 tables, one that keeps track of courses and another that keeps track of students and the courses those students are taking. Wait, that doesn't sound very modular, does it? We've always been talking about how modularity is important. But this table is not very modular, right? It has the information, the critical information about the student, and it has the courses that student is taking. Well, those are two different things. So how can we solve this knowing what we've talked about with modularity before? What did we do when software code was not modular? Anyone? Just type into Twitch chat. Right, we split it up. Exactly. When we had not modular objects, we had objects that weren't modular, we split them up into separate objects. Now we have a table that's not modular, so let's make another table. That's what we want to do. And so, the way we're going to solve this problem is we're going to create a table that maintains the students and their critical information. We're going to create a table that maintains the course information, things like the CRN, the subject, the number, the section number, the meeting time, and we're going to maintain a separate table that keeps track of what courses students are registered for. And now, in order to make sure this table only has one primary key, we can do just insert a column ID and just make this an auto increment. And now this table has a primary key, but it keeps track of each student and the course they are taking. So, in order to do this, what we first need to recognize is that these tables are inexorably linked. That is to say, and I'm just going to draw on top of this here, this field is directly connected I'm looking for a color that shows up well. Let me increase the weight even more. This student number field is inexorably connected to the student number field in the student table. Further, this CRN is connected to the CRN in that table, and I can change the color here. So these relationships matter, and here's why. What happens if I try to say something like, and I have a table here, if I try to add a field like ID 8, this is student number 12, and CRN 42069, lol. I realize I'm 14. The point being, this CRN does not exist, and this student number does not exist. Should we allow this record to be added to the table? Should we allow it? Regardless whether or not we know how to, should we allow it? Should we allow this table to contain a student that doesn't exist or CRN? So you're saying that we should just add a student? Okay, what is student ID 12's name? I'll go ahead and add it to the table now. What is their name? Well, we don't know, because 12 doesn't tell me anything about the name. The 12 is supposed to connect the student to tell me about the name. So I can't just add student number 12 because I don't know who student number 12 is. Student number 12 doesn't exist. So the point is, I should not allow any records to be added to this table that have no data integrity to the data they're referencing. That is, I'm not defining students here, I'm only using students. So I should only use students that already exist over in the students table. Same with courses. I'm not creating courses here. I should only use the courses that already exist. So if someone tries to add this table, I am going to reject it. In fact, I'm going to go so far as to even strike through this, just so everyone knows that this is not allowed. By the way, that's how you do strike through text in PowerPoint, if you didn't know. Anyway. And there's a means to do this within SQL, and it is called the foreign key. And the foreign key, it's similar to a primary key. A primary key is a constraint. It says that this primary key is a unique identifier for this row. It must be not null, that is not blank, and it must be unique, that is not repeated anywhere else in that column. A foreign key says this is a reference to another table. And the way we would do this, and I've actually already created this database, is here. Hang on. Is here. So I'm going to start by pointing out that everything above this line is unchanged. This is all from our init from yesterday, except for drop table courses taken, because we haven't added that table yet, but you can always drop the table. This would be generally how you do a script. You drop the tables because you're replacing them. From there, I define my courses taken. It had 3 columns. It had an auto-incrementing not null primary key. And here I define courses taken ID. And here I define the primary key. It has a student number, which is an int. And it has a CRN, which is an int. But I'm going to go one step further. I'm now going to say foreign key student number references students student number. What this means is that go to the table students and go to the column student number. And by the way, I'm going to delete this for now. We'll come back to the on delete cascade in a bit. But that says this student number is a reference to a student number in the students table. Similarly, this CRN is a reference to the CRN in course number. And if I use this script, and what I'm going to do real quick is I'm going to use, and it's going to be SDE day 2. So I'm currently in SDE day 2. I'm going to run this script, source day2.sql. Oops. And don't worry too much about this error down here. I'll get to what caused it in a second. And then from there, I've created that database. And if I do select star from courses taken, you'll see that here is my database. It is the student number and the CRN they take. And the idea is each record is a different instance of a student taking a course. Now, from there, let's say I were to insert this value. And this is actually where my error comes from. So I'm inserting student number 5, taking course 1, 2, 3, 4, 5. Well, if you look at my students, select star from students, you'll notice I don't yet have a student with ID number 5. It just doesn't exist. So when I try to insert into courses taken, and I'm going to insert into student number CRN values 5, 1, 2, 3, 4, 5, I get this error, and this error says cannot add or update child row. A foreign key constraint fails. Specifically, the constraint that fails is connecting the value student number to the table students value student number. So this is saying effectively that this query returned nothing. Select star from students where student number equals 5. Because this query returned the empty set, I cannot add this to my table because the student number doesn't exist. So this ensures data integrity. By that I mean all the data in my courses taken table is valid. all the students exist and all the courses exist. It makes sure of that. If I try to add a course that doesn't exist or a student that doesn't exist or both, that data will not even be added. It will be rejected automatically, which is very useful because that takes the problem of maintaining degraded integrity out of my hands as a developer and automates it, which is very useful. There's a trade-off. Let's say, for example, Jack White were to say drop out of this hypothetical school that we're creating. So I were to say something like delete from students John. Delete from students where last name equals White. Because I remember there is a Jack White. I can't do this. I can't delete the data. And the reason I can't delete the data is because a foreign key constraint would fail in the resulting database. The problem is I would be deleting, so Jack White's student number is 4. I would be deleting this record, but this one would still be left behind. And the problem with this is this student number 4 would no longer exist. So if I wanted to delete the student Jack White, I would first have to say delete from courses taken where student number equals 4, and then I could write the previous query. But because I before tried to just run this without deleting this record, it didn't work. And if you look now, by the way, you can just hit up to go through your previous commands. Quite useful. Select star from students. Yes, so the bacon, what you're pointing out is exactly correct. Is there a way to do it all in one line? Yes, there is, and the bacon was on the correct path. So the first thing I'm going to do, I'm going to reset my database. So I'm just going to do day2.sql, source day2.sql. That will reset my database. And then from there, I'm going to add this line to my foreign key on delete cascade. And I'm going to add it to both lines. And what this will do is anytime the reference gets deleted, specifically the reference meaning the student number in the students table gets deleted, it will cascade that change. Think of it like a waterfall. That's what a cascade generally is referencing. It's a waterfall. So if you think of the table that has the dependency as the lake at the bottom of the waterfall. So that lake is the courses taken. And we have two separate rivers feeding waterfalls, students and courses. If we delete something from students, that change falls over the waterfall into the lake at the bottom. It cascades downward and propagates the change. And if I do that, and I reset my database real quick, let me make sure I save that file. So I'm resetting my database. Oops. Hang on. I think I did something wrong here. Let me take a look. I did this when I practiced too. On cascade delete. Oops. I got it backwards. On delete cascade. My bad. And if I set my table up this way, which remember, we have to set the table up this way to begin with, and there is, by the way, a way to add constraints. There's an alter table command, but it's one of those things where I'm not going to quiz you on it. I'm not going to test you on it. I would just say go back and set your table up right the first time for the problems we're dealing with. If you want to later apply this, you can certainly look that up, but it's not going to be something I'm going to test you on. Anyway, I am going to test you on delete cascade, what that does, but not like how to add it to a table after creation time. So I run my source file, and now I'm going to do So first, select star from courses taken, and select star from students. And now what happens if I do delete from students where student number equals 4? Notice this time the change went through. And if I select from students, it's gone. Also, if I then select from courses taken, you'll see that before, where we had 7, where 4, where Jack White was taking an APMA course, now that record is gone. It's not there anymore. So that's the way to do it automatically, is to add in the on delete cascade to the, in this case, the bridge table. So specifically the table that bridges courses and students, because that's effectively what this table is doing. It's kind of combining those two elements. But now we have an interesting dilemma, because now we have 3 tables. We already know how to query one table. How do we query 3 tables? Let's take, for example, I'm teaching, of course. In this case, the course is CS 2501 section 300, and my CRN is 12345. Nice and easy to remember. How am I going to get the list of students in my class from this database? That's a question. And the tools we have so far aren't enough to tell us, so we need some new tools. And this tool is called a join. I'm going to do select student number from courses taken join courses. So what I'm doing is I'm combining 2 tables here. I'm going to join them on courses.crn equals courses-taken.crn. So this is the first step. I'm combining these 2 tables, and I'm combining the tables only when the CRNs are equal between the 2 tables. This is to make sure that the class that is being referenced here is reflected in the courses table elements. And then something like where section number equals 300. Oh, sorry, not section number, it's just section. So let me redo this query. Where section equals 300. And there we go. This join, effectively what happens, I want to show you first what happens if I don't add an on statement. So select courses, let's do star from courses taken, join courses. This is what's going to happen. And if you take a look at this, what you'll realize is that it combines every combination. That is to say, I have, notice, the ID for course taken 3 times. The ID 3 times. Well, I have 3 courses. So what this does, this statement, select star from join courses taken, join courses, is it combines pairwise every possible combination of elements from table 1 to elements to table 2. So row 1 to row 1, 2, 3. Row 2 to row 1, 2, 3. Row 3 to row 1, 2, 3. When I add the on statement, that filters out all the places except where the CRNs are equal. So, on courses taken, that is from the table courses taken.crn, equals courses.crn. And if you'll notice here, now all these CRNs match up perfectly. And we've removed all the places where they don't match up. So the field names are not case sensitive. Pretty much nothing in SQL is case sensitive. I forgot to I mentioned that briefly at the beginning, but I didn't mention it on Monday or on Tuesday. Nothing in SQL pretty much is case sensitive, which is convenient. Um, there are certain styles that are probably popular, but admittedly, I'm not. I don't do enough SQL to really know that. So anyway, so now that we have this table, now I could get the student IDs of the people in section 300, specifically these three. So that's where we add where section equals 300. So realize each step along the way. This join just combines every possible combination. The on statement is used to filter out only things that match. And then from there, we add our where clause to filter further. The problem here is, what if I want the student names? Well, if I want the student names, I need to match these student numbers to the student names. And there's a couple ways to do that. The easiest way is a nested query. And the way I'm going to do this is, first, I'm going to select that query. But I'm only going to do first the student number. So this only gives me the student numbers of students that are in section 300. The next thing I'm going to do is I'm going to take this query that produced that, and I'm going to copy it. And I'm going to paste it over into a new file where I'm just going to use the workspace. And file, save as, temp.sql. The reason I do this is it adds in the text highlighting. And just to make this easier to read, I'm going to add in some line breaks and add in some tabs. So this is a query. And by the way, a SQL comment is hyphen hyphen. This query gets the student numbers of students in the course I'm taking. From there, I can do the following. First, I want to get students' first and last names. So I'm going to do select last name, comma, first name from students. And let me enter tab. But I'm going to use a new keyword here, where student number in, and this in means the student number is in some list of student numbers. Well, where do I get a list of student numbers from? Well, how about I just use it from this query? After all, we already know this query gives me a list of student numbers. I've already shown it right here. Close the parenthesis, and now paste that, and there you go. I now have the list of students in my class by their name. First, I select the student numbers. I then use those student numbers in a query in this way to select the name. Now, there's another way to do this. You could also do select last name, first name from students, join courses taken on students student number equal courses taken dot student number. Join courses on courses taken dot crn equals courses dot crn, where section equals 300. This should work as well, barring some maybe syntax errors or spelling errors. Let me give this a shot. Nope, that worked fine as well. So these two queries do the same thing, but I find sometimes it's easier to think of nesting these queries as opposed to trying to work out all the joins in one place. But just as a reminder of what this table is going to look like, I'm just going to quickly show you this query without the where condition is going to give me, in this case, let me do select star actually. One second. There we go. This gives me all the information for each student, the course they're registered for, all in one place. Although, if you notice, once the table gets too wide, it kind of can get harder to read. Um, you'll see that here. It gets a bit harder to read just because the screen is too wide. You can turn off wrap text if you want to in properties. But for various reasons, I'm going to keep it on. Point being, though, this is a way to merge all the tables together, and then you can add in the fields you want instead of star, and you can add where conditions. Some other things worth noting, there are, for example, such MySQL phrases as sorted by. One thing I could do is this. Um, let's say I wanted to get the count of student numbers. I could do select, let's go with subject number from courses where, or from courses, and then I'm going to do join courses taken, and same statement here, so I'm just going to copy paste it. So first, I can do this. Oops. Oops. Um, hang on, what did it not like? Something is a bit strange here. Select subject number from courses. Okay, that worked. Oh, I see what I did wrong. I see what I did wrong. I had the wrong table here. This should be courses taken. My mistake. Okay, must not have copied it correctly. And this is giving me, because every student's registered, this is effectively giving me the number of students that are in that course subject. I can then do, and actually forgive me one second. From there, I can actually add in a second little condition, which is to say, let's do count, and let's do student number. And if I add this in, why is it not copying correctly? My keyboard's kind of acting up today. Apologies. If I add this in, sorry, my keyboard's really, there we go. You'll notice that now I have, in this case, it's giving me a result 6. Actually, I did this Wrong here. I forgot the words group by. Um, Silly me to forget that. Sorry. We're going to do group by. Sorry, not underscore. Group by, and then it's going to be CRN. And let's do specifically courses.crn. So we're going to group the courses by their CRN. Copy that. It's really, I don't know why all of a sudden it's just not copying correctly. It's kind of frustrating me. There we go. Okay. Now it'll let me paste. Will it? Sorry. I'm just going to do the right click copy because it seems to not want to work. There we go. And now you'll see that this gives me, I'll put this query up again. This query is giving me the count, that is the number of students in each course. And what I'm doing is I'm listing the subject and the number, and I'm listing the count of student number, but specifically I need to group the courses by their CRN. And so this gives me the number of students registered in each course in my table. And if you want, we can verify, select star from courses, select star from courses taken, and you'll see that we have for 1, 2, 3, 4, 5, we have 1, 2, 3 students. For 5, 4, 3, 2, 1, we have 1, 2 students, and for 9, 8, 7, 6, 5, we have 1 student. So that matches up with this data. And there's a number of these things besides count. For example, you can get maximum, minimum, average, etc. Sum. You can get the sum. Um, there's too many to list. What I will say is you can look them up as you need them. I'm actually going to recommend, and this may sound crazy, the W3 Schools website on SQL is exceptional. It's actually really good, and it's normally like the popular website's kind of bad and stuff. But this website, W3 Schools, and you can see I actually just looked it up because I forgot whether or not group by had an underscore or not. W3 Schools SQL is actually fantastic. It's a really good website. I reference it all the time. So if you're referencing this during the homework or because this course is online, quizzes or exams, that's fine. I swear by this website when I'm doing SQL stuff. I also use it actually for PHP. I don't like it for Python personally. I like the main Python website for that, but nonetheless, to use Geeks for Geeks. I have not used Geeks for Geeks. That doesn't mean I strictly recommend against it. From my perspective as a professor, because this is not an intro programming class, I'm fine with you using any resource that isn't explicitly, hey, here's code that already does the assignment that you can just download and copy and paste. I don't want like the entire assignment, but if you're using any website, Stack Overflow, Geeks for Geeks, whatever, for helping with just little details or little things, in this class, I support that. If this were 2110, where I'm teaching intro Java, I'm a bit more hesitant. If this were 1111, where I teach just intro programming, I would actually avoid it and ban it. And the simple reason for that is at that point, you're still learning. You're not really prepared to read and understand what's presented there. But yeah, I don't have a problem with that. There are a few websites I know that like Course Hero and Chegg, where people just post solutions to assignments, and certainly those are not acceptable. That said, if someone posts something on like Chegg that's just, hey, here's a little tip, I guess I'm okay with that, but I know what Chegg gets used for. And by the way, we do have an account, the professors, that we share, and we go on Chegg and see which of our assignments are posted, and we include those solutions in our cheat checker. So in case you were ever wondering, so we know it exists. But yeah, Geeks for Geeks, I don't think is that. I think Geeks for Geeks is like Stack Overflow, if I'm not mistaken. But I can't recall. I love this W3 Schools website. I mean, honestly, this tutorial, everything I've done in lectures covered here, and I think it's quite fantastic. So just W3 Schools / SQL. All right, we're getting close to time here. I certainly want to allow time for questions. Are there any questions about the queries I wrote here? And I will upload these queries um, just as examples, and I'll leave little comments saying what they each do. I will also upload the slides. I will upload the Java file. I will upload this day 2 database file, and I encourage you to go and play with the database. Try to add data to the database. Try to take away data from the database. Things like that, just to get some practice. And then homework 6 should be out today. By today, I mean it might be like technically like 1 a.m. in the morning at the rate I'm getting things done, but I will do my best to get it out today. Any other questions? Otherwise, that's our unit on SQL. We're going to get back into design starting on next Tuesday. So we're going to talk about 3-tier architecture Tuesday, which I've actually already talked about, but I'm just going to break down different ways to use it. We're then going to talk about integration. What order should you implement things in? How can you implement things other than a bottom-up order? We'll talk about that. For instance, how can you do top-down integration? And then from there, the rest of the course is design patterns until the final exam. But with that, certainly I'll take any questions. Otherwise, that's all the new material I'll present today. And I hope everyone has a good weekend. I hope everyone does well on homework 5. And I will see everyone on Tuesday. By the way, there is a third normal form, and there's actually technically a fourth and a fifth, but they get more nebulous. Third normal form has to do with functional independence, and then it gets even more nebulous from there. So I'm not really bothering with those. So for the sake of the homework, I'll say your database needs to be in second normal form, and that just basically means create a bridge table between the two tables. I have Kitty sleeping adorably on the couch. If people want to see that, let me get my camera here. Oh, Stewie's kind of waking up. Yeah, you can see my house is still a mess, but look at them snuggle. They sleep together like that all the time. It's absolutely adorable. I can't really zoom in with this camera, but that is Stuart and Colby. They love each other very, very much. It's adorable. Oh, I'm really showing off like how dirty my house is right now. It's pretty bad. The reason I have two TVs down here, by the way, is my bigger TV is for it only has HDMI ports. So like if I want to play classic games, I can't play it on that TV. So I have the other TV. I haven't been playing video games at all lately, but that's just been this semester. All right. Well, I guess I will wrap it up there since I haven't seen any questions. And take care, everyone. Bye.